So mathematics really is the language of computer science, which means that while you're working with PowerShell or maybe in some other language, you're going to stumble across some numbers that aren't done with 10 digits. We're talking about base 2 and base 16, and there may be some times when you need to convert between them. So that is what this particular episode is about. We're going to be taking a look at some PowerShell code so you can do those numerical conversions on demand. So in the computer science world, our basic number system is binary. 0, which means there's no electrical power, and 1, which means there is. But for us to represent out a number, that can get kind of long and really hard to read. So what we can do is we can break our binary numbers down into 4s. So with hexadecimal, it has 16 possible values. 0 through 9, then A, B, C, D, E, and F. 16 values. So when you have 4 binary numbers, all the possible combinations come up with exactly 16. So essentially, this is just a way of representing these long binary numbers in a more compact fashion. So we're going to start off with binary, and this is my binary number. So I'm going to use the .NET convert object, and we're going to convert it to a string, but at base 16. And when we do that, we can see our output. Down here is 199D2AAB, 8B2. Now, one of the things that I've noticed when I'm working with hexadecimal values, particularly when I may be working with APIs, I interface with the Coinbase API in some of my software, and they want it in uppercase. So if that's going to be one of your requirements, then all we have to do is add the 2 upper to the end of the string, and there you go. You have the letter parts of a hexadecimal number is now in uppercase characters. But what about converting base 10 to base 16? Again, I'm going to use the convert.NET objects, and the first number is going to be the number in base 10 I want to convert, and the second number is the base number of 16, which is hexadecimal. And we run that, we can see that 154 is actually 9A in hexadecimal. Now, for those of you who are more familiar with or more comfortable with using the .NET formatting strings, the X formatting string is going to convert things to hexadecimal. So here we go. And that number 4 just simply says how many digits in hexadecimal do I want to see. Next, we're going to go something that's going to be a little bit more familiar. We're going to convert binary and hexadecimal into base 10, which of course is the numbering system that we use. So first of all here, I have my number in binary, and I'm using that convert operator, and we're going to run this, and you can see it converts it to 178. So it went from base 2, binary, to base 10, which is decimal. Or how about going from hexadecimal into decimal? So here I have the hexadecimal value FA, and you can see it's base 16. When I run it, it's going to show you that the number is 250. But there's a little bit of problem here because you guys can see that I'm using the toInt or toInteger method. It's a 32-bit integer. But what if this hexadecimal value is going to be too large for a 32-bit integer like this? We're going to receive an error. The value was too large or too small for a 32-bit integer object. So what you could do is tell this to convert it into a 64-bit integer. And when we do that, we're not going to have any issues. It does convert it successfully to decimal. All right, let's convert our numbers to binary. First up, I have a decimal value of 100. I'm going to use the toString method of the convert object, and we're going to specify convert it to binary by giving it the number 2. And when we do that, you can see that this is the number 100 in binary. But what about converting hexadecimal? Well, for this one, I kind of had to do things twice. So let me show you. Right here, I am calling the convert object, and I'm going to convert FA into a decimal value. Then I'm going to convert that value into binary. And there you have it. It works. Now we represent binary numbers in decimal. Think about when you're doing subnetting and you've got to do a subnet mask for an IP address. Remember that 255.255.0.0? Well, that 255, if you calculate it out, that's 8 bits, all with the value set to 1. Hexadecimal values can be found in things like encryption algorithms, checksums, error codes, bitmaps. So we use all 3 of those numbering systems in the computer science world. All right, hope you guys enjoyed this and picked up a few tips so when you need to do numerical conversions, you now know how to do it with PowerShell. Take care. See y'all next time.